The early 90s were full of good things. Neon wine workers glowing under shopping mall lights, cassette tapes tangled inside Walkmans, Super Nintendo controllers glued to kids' hands, and families stopping at fast food counters after school. It was a colorful decade, carefree, loud, unforgettable. But even in good times, unexpected dangers can hide in plain sight. Few imagine that a simple fast food hamburger could spark a global revolution in food safety. Yet, in January 1993, the United States faced an outbreak so severe that it exposed the deepest cracks in meat inspection systems and forced the world to rethink how we protect our food.
Health officials say people infected with the E. coli bacteria may be unknowingly infecting others. More than 150 people have become ill after eating tainted hamburger meat at Jack in the Box restaurants in Idaho and Washington state. One child has died. Steve Williams reports.
Before the outbreak, food inspection in the United States relied mostly on organoleptic inspection, looking at meat, smelling it, and touching it. It worked against visible spoilage, but not against microscopic killers. Across the world, there were already signs that food safety systems were outdated. In the United Kingdom, the BCE crisis was shaking public trust. Meanwhile, in the US, the industry was slowly discussing a scientific system called HACCP.
HACCP stands for Hazard Analysis and Critical Control Points. It is a systematic approach that identifies, evaluates, and controls food safety hazards. Originating in the 1960s for NASA's space program, HACCP has evolved into a mandatory requirement in the food industry worldwide.
In early January 1993, Seattle hospitals report children suffering from hemolytic uremic syndrome, a dangerous condition that destroys red blood cells and damages the kidneys. Investigators traced the infections to undercooked hamburgers served in Jack in the Box.
The contaminated products were regular-sized hamburger patties and jumbo patties produced by Buns Companies of California, distributed to 73 Jack in the Box locations across 4 states. More than 700 people fell ill, nearly 200 were hospitalized, and 4 children under the age of 10 died.
The outbreak began before the meat ever reached the restaurant. E. coli O157H7 entered the supply chain undetected. HACCP was voluntary. Microbial testing was not routine, and the US lacked a mandatory standardized system to prevent hazards. Investigators identified 5 slaughterhouses in the US and 1 in Canada as potential sources of contamination. The trail eventually led to Buns Companies of California, the supplier of the beef patties carrying the deadly strain. What occurred was a classic case of farm-to-fork contamination. During slaughter, intestinal contents containing the pathogen came into contact with meat surfaces. Subsequent grinding of the beef spread the contamination through the product.
Jack in the Box had been warned repeatedly that their hamburgers were undercooked, but management refused to risk cooking temperatures because 155 Fahrenheit degrees made the patties too tough. The choice of E. coli to survive, and meal heating can even stimulate toxin production in certain conditions.
E. coli O157H7 is a gram-negative, non-spore-forming mesophilic facultative anaerobe that naturally resides in cattle. Its infectious dose is extremely low, as few as 10 to 100 cells, making it especially dangerous for children. This strain carries bacteriophage genes that enable production of Shiga toxin, one of the most potent agents in foodborne diseases. The bacteria typically do not produce significant amounts of the toxin in food itself. Instead, once contaminated food is ingested, E. coli survives stomach acid, attaches to the intestinal lining, and begins producing Shiga toxin.
The toxin binds to GB3 receptors, like sphingolipid molecules on enterocytes and kidney endothelial cells, allowing entry into the cell. Inside, it blocks protein synthesis, triggers apoptosis, and activates coagulation, forming microthrombi in blood vessels. These clots shred red blood cells, consume platelets, and impair kidney function. Locally, this cascade causes hemorrhagic colitis, bloody diarrhea, and severe intestinal injury. If the toxin escapes into the bloodstream, it further targets kidney endothelial cells and may extend to the brain, leading to hemolytic uremic syndrome, acute renal failure, neurological complications, and, in the most tragic cases, death.
The organism thrives at 35 to 40 degrees Celsius, survives refrigeration as low as 6.5 degrees Celsius, and tolerates salt up to 6.5%. Cooking destroys the bacteria at 71 degrees Celsius, but standard cooking temperatures do not reliably destroy the toxin.
To inactivate gigatoxin, food will need to be heated to 85 Celsius degrees for at least 1 minute. This is far above typical cooking temperatures, meaning that preventing toxin formation is the only practical control.
At the industrial level, validated lethality steps can drastically reduce pathogens. These interventions are now standard, but in 1993 they were not mandatory.
Jack in the Box and Foodmaker faced the largest settlement of the time. One of the most tragic cases was that of a 9-year-old Brian Kinner. He suffered hemolytic uremic syndrome, a coma, and permanent health damage. Her case resulted in a $15.6 million settlement, the largest individual payment ever made for a foodborne illness. Public blame was assigned to Buns companies for selling contaminated meat. The verdict was clear: negligence at every level of the chain, from slaughterhouse to restaurant, turned a simple hamburger into a deadly weapon.
The outbreak was severe enough to appear in President Bill Clinton's very first cabinet meeting. By mid-1993, E. coli O157H7 was declared an adulterant in ground beef. Zero fecal tolerance was enforced, and HACCP became mandatory across all federally inspected meat and poultry plants. In 1996, USDA released the Pathogen Reduction HACCP Systems Rule, the most sweeping reform in U.S. food safety history. The rule introduced mandatory HACCP microbial testing, documentation, and scientific controls. Globally, Codex Alimentarius adopted an HACCP. Retailers later pushed for third-party certification systems like GFSI, BRC, SQF, and ISO 22000. By 2001, E. coli O157H7 infections dropped 46%, achieving national public health goals years ahead of schedule. Now that we understand the biology and the systematic failures, a painful question remains. What should have been done so that no child died at Jack in the Box? The answer is clear.
The outbreak was preventable by proper HCCP, real testing, validated lethality, safe cooking, and awarenesses of E. coli larvae infections dose. If these measures were in place, even half of them, those children will be alive today. Science exists, the interventions exist, but the system simply failed to use them. Are we prepared for the next preventable tragedy?
The answer is no. We are not yet fully prepared. We must continue to learn from past failures in food safety. E. coli O157H7 still causes an estimated of 63,000 illnesses each year in the U.S., with ground beef remaining a major vehicle of transmission. Yet, beef is not the only source. Leafy greens, sprouts, unpasteurized milk, and juices, and contaminated water can also carry this lethal strain. As consumers, we can take simple but powerful steps to protect ourselves and our families. Food safety is not optional. It is the line between prevention and tragedy.